super friends, sorry to keep you waiting. So I acknowledge the traditional owners of this land and I pay my respects to their elders past and present and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And yes, I know, I am really late. I'm sorry. I did warn on Discord that last night that I was probably going to end up being a bit late today because, well, just wondering if this is doxing him. I probably shouldn't say this, but it's my dad's birthday today. And so, ooh, I'm getting a buffering warning on YouTube, which is interesting. I wonder if it's working okay. So, and because of lockdowns and everything, we couldn't do any of the normal birthday stuff. So we had like a family video call, and my brother is in Western Australia with his little baby and his wife, and one of my sisters lives not that far away from me, only like 7 or 8 k's away. My other sister is in Canberra, and so it was people from all over the place all jumping on and having a chat. And so yeah, anyway, that was important. So this ended up getting pushed back a little bit. Now I can see that a whole lot of people have been chatting in the chat. That's the best place for it. And it was buffering, seems to be working now. Thanks, Austin. And I have a feeling that it might have been happening at my end, but I don't know why. So maybe now it's already figured itself out. All right, okay. Now, it's got Miller Oxes everywhere. Yeah, there are a couple. There aren't very many. It's actually a very rare name. There aren't very many in Australia, and I think there are maybe 1 or 2 others that are not related to me, but it's basically my direct relatives, and that's about it. Just as a little teaser, this is what we're going to be looking at today, and we will get to that in just a moment. Oh, my, okay. I wonder if it's my computer. Oh, I've got way too much going. Oh no. You know what's going on? I've got Fusion 360 running. I'm going to quit out of that. Okay. I'm just switching to it so that I can quit before the stream totally freaks out. Johnny, you're probably due to too widescreen. Yes. Letterbox format. What else can I quit out of? Oh, Fusion 360 is doing something in the background and it is really not happy. I may even force quit it just because it's going to cause problems for different things. Oh, I've got Photoshop running. I was really not prepared. Okay. Oh, Fusion 360. I know it's not exactly exciting watching me. Sorry, I'm jumping around between screens because I've got to stuff it. I'm going to kill Fusion 360. Force quit. Fusion, force quit. Bye-bye. And maybe that will improve the situation. All right. And what else do we have? Probably not much else that I can quit out of for now. Okay, yes, Fusion 360 is not very happy on M1 Max when OBS is also running. It's okay when OBS is not running. I know, I am so disorganized this morning. I'm just clicking around and doing stuff. Why stream in 60 frames per second? I have no idea. Oh no, Aaron, a dedicated streaming Mac fund. No, I think I need to, you can see my hesitation about chasing that particular squirrel. I think I can, yeah, I don't know. I'm not going to talk about that right now. But maybe a dedicated streaming box is the way to do it. and then capture this desktop, so that what I have is this desktop going to a streaming box which also captures the cameras and all of that sort of thing. And I was hoping that that was what the box that's on the shelf down there would do, but it didn't. Xeon says, I only stream at 30 frames per second. I don't even know how to change the streaming rate settings. Is that in OBS? Why would it be streaming at 60 frames a second? I have no idea. Output. It's got a video bitrate set, but there is no... oh, it is set to 60 frames per second. What is going on there? Alright, I can probably change that, but I'm going to have to stop the stream and then start it again. I am going to do that very, very briefly. Yes, alright. I'm going to do it right now, early on, before we get too far into this. So this stream will probably go blank for a moment and then it will come back. Okay. Okay, and it says that it is streaming again. I've got no idea if I'm back. And I'm just imagining what the YouTube servers are going to be doing dealing with this. It is, particularly when it comes to post-processing this stream, because the first part of the stream was sent at 60 frames a second and now it's being sent at 30 frames a second. Some call it fun. No, I do not owe Fusion 360 an apology. I still think Fusion 360 is a problem. Okay. Now, what are we going to talk about today? What we're going to talk about is we are going to talk about the Open Extensible Rack System. Now, I will give the very brief background because I posted some pictures on Twitter and Facebook, and I have a feeling that we might have a bunch of people here who have come for the first time and don't know a whole lot of the history of how all of this came about. So I'll do a very brief recap, which might be useful for future reference anyway. Now, where this came about was many, many years ago, I built a rack mount light switch controller, and it's still 60. Need to check your YouTube settings in YouTube for the stream. Haha, okay. Yeah, I have a feeling that what's happened is that the stream began and with the source being sent at 60 frames a second, and then when I dropped the source and then changed back to 30, I think I'm sending data to YouTube at 30, but it is probably still maintaining the stream at 60. Yes, okay. Now, so what happened was I ended up building this light switch, and I know there's this whole thing in the Discord about it's not a light switch controller because it doesn't control light switches. It's the control board that receives the connections from all of the light switches, and when you use the light switches within your house, it then sends out events which are processed by the home automation system so that it can take action on your behalf and turn lights on and off or open and close. Oh no, the frame size has dropped. What is going on? This live stream is a disaster already. So the light switch controller, I'm going to continue calling it, the light switch controller project was a rack mount device that had a whole lot of RJ45 sockets on it, and you plug in connections that go out to the light switches in the house. So the thing is that in going through this project with other people, what really became clear is that if you are building a DIY rack mount project, there are certain things that you almost always need. Now, obviously, you always need an enclosure. So the very first question, of course, is where do you get an enclosure? And in my case, what I do is go off and buy a plastic rack mount enclosure. You can also get steel and aluminium and different off-the-shelf, just empty enclosures. And then you have to modify it. So you've got to cut all the holes in it and mount in it what you want. So you need an enclosure. Typically you will need some kind of a status display, not always, but typically a status display is really helpful because what you can do is things like show the network settings. Even if it's configured by DHCP, so you don't need a menu as such, it's very useful to be able to plug in a device, have it come up with a display. And my friend Andy, who is in the chat here, really likes putting little I2C OLEDs on things as well. And also John Spencer, who is possibly in the chat as well, does the same thing. So you put a tiny little OLED on a project, and when it boots up, you can display things like whether it's connected to Wi-Fi, what IP address it's been assigned, whatever else you want. And that can be really, really handy because it saves plugging in a USB cable and then talking to the device to find out how it's connected to the network. The information is just right there. So you need an enclosure, you need some kind of a display. Typically you will need a microcontroller board of some kind, like an AVR based board or an ESP based board or a Raspberry Pi or something, which is going to be the brains of the operation. You need Ethernet. If it's going to be permanently mounted in a rack, then you probably want a hardwired Ethernet connection. Ideally, you want power over Ethernet support, and also optionally like just a DC jack, like a 2.1mm, plug in a 12-volt plug pack, and you've got power for your device. And then you might want a USB connection on the front so that you can flash new firmware or do configuration. You might want a power indicator. So all of those sorts of things are common no matter what you're building. It doesn't matter if you're building a light switch controller or other projects that have been talked about in the Discord are things like a smoke detector management system or an output controller that drives relays. They all need those same basic things. So what we have is a whole lot of people who are reinventing the wheel and building DIY projects that have these elements in common. And so what is now very embarrassingly named the Open Extensible Rack System is taking those common elements and extracting them into a platform or a skeleton that can be used to build all sorts of other projects. So if you've got an idea for something that you want to build, like that smoke detector management system, then you don't need to start from scratch with I've got to select an enclosure, I have to get a display, I have to write the display drivers, I need the microcontroller board, I need Ethernet, how am I going to do PoE support? You don't have to worry about that stuff because there are modules that can take care of that for you, and then you build your specific functionality in the middle. So if we have a look at this, so this is the prototype that I've just been working on. I'm going to pull up the other prototype in a minute as well. In fact, this is the third prototype, the third generation, the first of the proper OXRS devices. This is the second device. So this is one that I made a couple of years ago, about 2 years ago, I think. And this is the second generation light switch controller. So it's got the Ethernet connection on there. There's a power LED. It's got 24 inputs for going to different light switches. There is an I2C OLED on the front, and then buttons on the front for menus. And this was modeled after the old Cobalt rack style menu system. So, up, down, right, left, and then enter and select and enter or something like that, whatever those were. And then a controller would sit in the back here. So this is where I was going with the light switch controller project. Now the thing is that the first generation is actually still in my rack. In fact, there are two of them. I've got two racks, one at each end of the house. So the first generation light switch controller in the plastic case, there are two of them currently running my house, and they've been doing that for years and years. This is the second generation, which was intended to replace it, and it never did. It's been sitting like it's been on my bench and hacked around on, and basically used as a development platform. And that's got the I/O board there. So then moving on to the third generation, so the first one, which could really be considered to be a proper OXRS prototype, we have this. So there is display on the left. So this is a 1.54 inch, I don't know what that is in metric, I should, 1.54 inch SPI LCD, so it's a TFT LCD, and then ignore everything in the middle, and over on the right we have Ethernet, USB, so there's a USB-C connector there, I'll just unplug that to get it out of the way, and a power indicator. So at the moment you can see there's nothing else plugged into this box, it's just Ethernet. And it's getting power over Ethernet coming in. There's an ESP32 in here, and it's communicating on the network. So we've got an SD card, etc. I won't go into the details of this right now because that's not the point. The point is that this controller takes care of the common stuff that you would want to use in whatever project. It gives you the ESP32 that you can use to run your code on it. It's got Ethernet. There's USB, so you can reflash it or do configuration. The power indicator. There is a pluggable screw terminal block in the back, so you can send power in from the back if you prefer to. It's not actually fitted because I haven't received them yet, but this is a PoE regulator module. That's the footprint just there. So the idea is that this will support 802.3 AF power over Ethernet. There are also jumpers on here so that you can do DIY power over Ethernet. So at the moment I'm just sending 12 volts down the Ethernet cable and the whole device is running off that. Then we've got an I2C header here and we've got an SPI header here. Now, if you look at this and delete the whole thing in the middle, just ignore it, as if that doesn't exist. We've got the enclosure, the display, and the controller over on this side. That is the fundamentals of the basic platform of the OXRS. And then the idea is that what you would do for whatever your project is, you would design a board or use modules or whatever you want to do to go in the middle right here. So this part of it is what is customized. And it means that you can focus on just this part and build whatever matters to you without having to do all of the other infrastructure parts of it, starting from scratch. So that's the basic premise of it. And in this case, what I've got here is the light switch breakout. So that's a 24-port breakout. But in the middle here, you could have, this could be a connector for security sensors, for example. You could have a board in here that does end-of-line detection, and it's got screw terminals or pluggable terminal blocks or something to go out to security sensors. Or it could be the smoke detector management system that I was talking about, or it could be an output controller. And then we've got the I2C connection here that allows the main control board to talk to it and do whatever it needs to do. So that is kind of what OXRS is. It's the convention of having, it's the convention in terms of things like the front panel cutouts. So one of the barriers to this, I've read almost none of the chat, but I just saw a second ago that Dodgy, was it Dodgy? Oh yeah, so Dodgy asked whether this was cut on my friend's CNC. No, it wasn't. So this metalwork was laser cut at, what are they called? Quality Metal Solutions, I think it is, in Bayswater. So I designed this in Fusion 360. So this design was several years ago. And they laser cut it, and then they've got a CNC folder, like a sheet folder. So I think it was 10 of these made just as a starting point. And the idea is it's not meant to be open like this. This was just because I was just learning about the sheet metal tool in Fusion 360, and it was a first attempt at building a simple chassis that I could use for experimenting with. So I didn't bother designing a cover or anything to go on it. It's just the base. But ultimately I would want to have a back on it. So we have power connectors on the back. I'm planning to put an XT60 connector and a 2.1mm DC jack on the back, and then they can come into the pluggable terminal block. So the starting point is the chassis with cutouts for the common elements like Ethernet, USB, power indicator, and the display over here, and with mounting holes. So at the moment what I've done is I've used riv nuts. If we turn this over, you can see the bottom of them just on here. So what I did was drill holes through the bottom of the steel and then fit riv nuts, and these are just M3 riv nuts. When the riv nuts are clinched down, it's a little bit hard to see them under there, but you can just see it there. They come up about 5 millimeters from the face of the base plate. So if you then use M3 bolts, you can screw the PCBs down into the riv nuts, and you can see here the controller is screwed down as well. So my plan is to have a standardized chassis design with these mounting locations for the PCB and these cutouts for the connectors on the front panel. And then for people who are into, say something like a typical person who is into hobby electronics, they may be quite capable of designing a PCB for the module, like the specific functionality that goes in the middle here, but something like designing the metalwork, having it custom made, there are big economies of scale that can kick in with that, and making these sorts of things by hand and making it really neat is hard. You can do it, but you know, I had to, for these front holes, I drilled these out and then used files. So I hand filed these into shape, and it was a real pain. I hated doing it. So being able to buy a chassis off the shelf and have all of the mechanicals defined would be really helpful. So basically the chassis is defined in terms of the cutouts. So what you have is a template for your board. So then you could go to, if you wanted to, you can design your own board. And there is a Raspberry Pi CM4 board. I've gone totally blank on who it is. So someone in the chat tell me. There is a Raspberry Pi CM4 control board being designed and just about to be fabricated that will fit this same footprint. It's a bit longer, but it has the same mounting holes, and it uses the exact same positions for the two connectors here. James, okay, so James has worked on it, that's right. And so the idea here is that you will be able to select the chassis that you want, possibly in multiple depths. The 1 and 2, you could have multiple height options. Pick the controller that you want. So you might want ESP32, like in this case. You might want a CM4. You might want like an ATmega 2560 based controller. It could be whatever you want. You might want a pass-through version with a Raspberry Pi in the back here, or a Nano ITX motherboard if you want to go, really high power. But you've got the flexibility to do that. So as long as the board is made to fit the same mounting holes and it fits the same mechanicals, you can drop it into the chassis. And you could have it drive the same LCD. You could talk to the same breakout boards, just different environments. So, yeah. Oh, Alistair said, I'm a bit over mounting holes in PCBs these days. I just include edge clips in my 3D printed cases. Yeah, that's a cool idea too. So there's been some, there have been some really interesting ideas in the Discord about mounting bases, like 3D printed mounts that go into the bottom of this and allow you to put modules anywhere you like. So it gives you flexibility. It's almost like a Lego-like approach where you have a grid of mounting holes that are 3D printed and you just glue them in, or you could snap off little pieces of them and glue them in. And then if you've got odd size modules, like maybe you've got a watchdog timer module and you want to attach that in here, or you've got some kind of a sensor that you want to attach, you could just glue down the mounting holes, which are 3D printed, and then attach your PCBs in there. So, software, I'll get onto that in just a second. Actually, no, what I'll do, so I've got to give a big shout out to, well, first, just generally to the members of the Superhouse Discord, because all of the discussion around this has been incredible. so many ideas and different things coming out of it. But in particular on the software side, we've got Sumner Boy and Moyne. Aaron has been doing a fair bit as well with software for different projects. And okay, so the really cool thing, this whole thing, this thing as you see it, this is an ESP32 based controller. Ben and Moyne were working on a version of this that runs on an AVR, and then it was modified to run on ESP32. This is a different LCD to what we were running before because it's SPI. And just yesterday, all of the software was pulled together and I installed it on this, and it worked like straight off first time. It is incredible, which is amazing when they don't even have the hardware. So Ben and Moyne have been doing the development for this, writing the code that runs on this without even having the hardware to run it on. Well, they've just been writing the code like no, type away, hit compile, it compiles, and totally unable to test their work. And I have the code running on this right now, and it works. It is amazing. At the moment, you can't really see this display. It's blanked out. You can just barely make out that there is something displayed on it, but the backlight is turned off. So if I press this button, you'll see the display come to life. And if I press these other buttons, so on the display, it's slightly out of focus, unfortunately, but we've got the Superhouse logo, the rack controller version number, the IP address, the MAC address, and now it's just gone blank again. And down across the bottom of the screen, there is a little grid which shows, well, basically that grid corresponds to all of the sockets on the front. And then each of these sockets has 4 possible inputs. There are 8 wires coming out of each socket. 4 of them are used for power, 4 of them are used for data inputs. So we can have 4 switches on the light switch. And it's going to be almost impossible for you to see, but down here, if I press this, you can see that just above my finger there is a little yellow block that is turning on and off as I press the button. And if I press this button, a different block turns on. So the LCD is displaying the status of the light switches that are plugged into it. And then as I'm pressing this, it's also publishing to MQTT. So all of those light switch events are being published, and it can do like single press and double press and triple press detection and all of those sorts of things, which is really, really cool. So I am really impressed with how the code has come together for that, which of course was not my work. I'm not taking credit for that. And then just over the last day or two, with Moyne and Aaron, and Ben, so it's been basically Aaron who has been working on putting this part together. We have this site. See if I can do a switch. So you can't, I'll just move this so you can see the URL. So we've got this site which is OXRS.io, which is currently running on GitHub Pages, and we've just been setting this up as a place to document all of this. And you can see there this same prototype in a partially assembled state. This was before I mounted the LCD, didn't have labels on it and that sort of thing. So that's the work in progress from a few days ago. And the idea here is to meet a couple of different needs. One is to make it easy for people who want to take advantage of this to build their own devices using the standards. So there's not a lot of documentation on here yet, but it's getting there. One of the things we want to do is put on mechanical information so that it'll do things like show, if I come back over to here, yeah, we'll have mechanical drawings for the positions of the cutouts on the front panel and the locations of the mounting holes and everything else. so that if you want to design your own module that just drops into this enclosure, everything is there for you. Now, of course, you could go along and just grab the project files for this, because the design for this PCB, it's all released, it's all open source, it's on GitHub already. So you could just grab this and modify it to suit your own needs, and all of the mechanicals would come along with it then. But yeah, we're going to do mechanical drawings and everything. Probably put up CAD files and stuff, so that it makes it really easy for people. So that if you want to make your own board that's going to drop mechanically in and just fit perfectly, you'll be able to do that. And likewise, things like the cutout, the location for the LCD on this side. So if you want to build your own LCD stuff, you can do that. And yeah, take care of the mechanical side of things. So that's one of the things that this is going to be for. This site is going to be a place to put information about the convention. I hesitate to call it a standard. It's a convention, and make it easy for someone to come along and say, okay, I want to build something. What are the dimensions that I should use? Where should I put the Ethernet connector? Where should I put the USB connector? And make it so that it will all just fit. So that's what this is about. And then it's also a place to consider to list compatible things, because there are already people working on this. Now, if we go to makers, for example, is it going to load? I don't know. Oh yes, it is. Yeah, I think my internet connection is having a hard time today. Yes, it is just taking a really long time to load that page. Mike said, software worked first time, inconceivable. Yes, and Scott, Ben and Moyne may have sold their souls. I think they're magicians. There's something going on. And I am having trouble loading the... all right, let's try boards. Is that going to load? Okay, maybe I just needed to reload. Yeah, this is better. Okay. So what we've done is we've got a couple of maker designations here, and these are the people that are already working on boards that follow this convention. And if we go to hardware, oh, unfortunately my face is in the way there. How about I move my face? I'll get rid of it. Move it over there. Okay, so what we've got here is sections for different types of devices, and this whole site is only like a day old, 2 days old. It's just coming together. But what we've got is a section for controllers, and the Rack 32 is that one that's in this current prototype. So there's just a picture of it, information about it, and links to firmware that you can run on it. So for example, you wanted to use this as a light switch controller, you would run the state monitor firmware. If you wanted to use it as an output controller, you'd run the state controller firmware. If you want to use the smoke detector management system, you'd use the smoke detector firmware, etc. And then there's going to be more stuff on here. FAQs, does it come with a power supply? Yes, I need to supply some FAQs. I need some questions first. And then there will be, oh, compatible hardware? Yeah, okay. So this will be a place to have a guide for all the different modules. And so I know that there are others probably coming sometime, maybe from dentistries. So where were we? Yeah, there's probably going to be an AVR, and James is working on a CM4 board, so there's going to be more here. And over time this will expand, I hope, to include different boards that can drop into the same chassis. And then input devices, a lot of this is still blank yet. It's just templates. We need to fill that out. This is one of the Bedrock Media Designs boards as a universal input-output UIO board, 16 port, with information about that. and then there's also my 816 and 24 port boards that will need to be added in here, and also the 32 port. So for those of you who asked for it, there is now a 32 port version as well. I haven't actually fabricated it yet, but all the design is done. Oh, Ben says that is actually the smoke detector board renamed from UIO. Okay, cool. So that's a smoke detector management board. Groovy. Anyway, as I said, this whole site is only like under 48 hours old. So it's just a template, and at the moment, and some basic content just started being pulled together. So what we're going to do is start adding in, oh, once again, you can't see because my face is in the way. In the navigation up here, we're going to start pulling in guides for like mechanical guides and things. And also there is a whole firmware thing as well. So hardware, where have we got? Guides, firmware and libraries. Okay, so there's no stuff linked there yet, but there is heaps on GitHub already. And if we go to the Superhouse GitHub account, there's the OXRS updated 1 hour ago. Ooh, looks like someone has been doing updates. What was the latest update? Fixed typos. Okay, thanks, Aaron. And there are a couple of other bits of software here. So there is the firmware and there are the libraries. So this is another part of it. The idea is to make this modular and as easy as possible. Okay, so let me rephrase this. The whole point of this project is to stop you having to reinvent things. So if you have a specific need in mind, say you wanted to make an audio switching matrix, or, you know, as we've just been looking at, a smoke detector management system or whatever, what you should have to think about are the specifics of the application of the project that you're building. You shouldn't have to worry about the chassis, the controller, how am I going to drive the LCD to show the status, how am I going to connect to the network, how am I going to connect to the MQTT broker, all of those sorts of things. So there are the interchangeable hardware modules and also the supporting libraries for the different bits of functionality. So for example, there is this library, which is the LCD library, and it handles setting up the connection to the screen so that you can, all you need to do in your project is include this library and you can just write to the screen. You don't have to worry about the details of how that happens. And similarly there is, so if you look at the -lib things in here, there's the IO handler, there's the MQTT library, and there's also the OLED library, which is probably about to be deleted because one of the things we need to decide is what we're going to support. And the original prototype uses OLED, and then I switched to an SPI LCD, and so after a discussion with Ben kind of last night and this morning, we've come to the conclusion that we should probably drop support for the OLED so that we're not trying to maintain things like two different formats for the output. When you display on the screen, you should expect you're always going to get a 240 by 240 screen. There shouldn't be a situation where in your code you're trying to figure out how am I going to have two different display methods for this. So yeah, anyway, that's probably going to go away, but we have libraries for driving these different things. And then there are the firmware, so the -FW projects are for things, oh, and the IO handler. So this is for doing things like talking to the MCP 23017s and just doing general IO stuff. So if you want to do basic IO, once again, you shouldn't have to re-implement that. You can just use this library. Then, if we look at this one, the state monitor ESP firmware. So this is the firmware that's running on that board that I've got on my desk right now. And it monitors all of the inputs and then publishes events to MQTT, it can be reconfigured by publishing to MQTT. So you can send it configuration commands and do things like change modes of inputs and all sorts of stuff. So you publish to a configuration topic and the controller sees that and reconfigures itself. But yeah, this one, if I go into here, what you'll see is that it uses the, well, this hasn't been deleted yet, it's still got the OLED stuff in there, but it uses the I/O library, it uses the LCD library, it uses the OXRS MQTT library, and so none of that stuff has to be re-implemented. So the firmware can just worry about its specific job. It doesn't need to worry about the rest of it. Okay, so what should I kind of run out of breath. I need to I need to take a breather and a drink. All right. Out of the corner of my eye, I've been seeing that the chat has been running pretty busy and I have not been reading it. Now, what have I been missing? I don't know. I just saw Sion say, "Wow, such fantastic progress over the last week." Yeah, it it has been, but it hasn't been me. It's mostly been driven by Aaron, Ben, and Moyne, who have been frantically putting stuff together. I've just been focusing on building this hardware. Oh, and so in terms of the hardware, okay, I'll start talking about designators and things in a moment. But if I view all repositories, so the Rack32 is that controller. And so yeah, I've been focusing on things like the Rack32 and the RJ45 breakout. So you can see here there's the 8-port version, 16-port and 24-port version, and this repo has not yet been updated with the, I'm going to live dangerously and open Eagle. It has not yet been updated with the 32-port version, and I finished the design on all of that and then haven't pushed it to GitHub yet. So I need to do that. I am just having a quick look in Eagle. Where are we? I do see RJ45. This is it, although trying to make it fit. Some of you would have seen that tweet I did earlier, which was the picture of this on the 49-inch ultra-wide monitor. And the funny thing is, if you look at, so this is the 32-port version of the RJ45 thing. If you look at the aspect ratio of this highlighted area right there, that is approximately the aspect ratio of my monitor, which is just ridiculous. So it's the 49-inch ultra wide is absolutely perfect with this particular PCB zoomed in to fit within the screen. It's like there's almost no wasted space around it. It just fills the monitor. So yeah, every PCB I work on from now on is going to be in this aspect ratio. So this is the, yeah, this is all done. It's ready to go. I'm actually going to send this off for fabrication, but there's a project at the moment for the Open Hardware Miniconf where we're going to be doing an FPGA based board, and that PCB is going to be hopefully ready to send off for fabrication in a couple of days' time, maybe Wednesday-ish or so. So my plan is, for saving on shipping, I'm going to order some of these 32-port boards at the same time as the Open Hardware Miniconf boards. So they'll all go through on the same production run at JLC PCB and end up in the same DHL shipment. So probably in about My guess is about 10 days or so, give or take, allowing for a fudge factor. I will have the bare PCBs in my hands for this 32 port version. And if I go, in fact, if I go back to the overhead view, so you can see this, when I was laying this out, like assembling this prototype, my positioning on this 24 port breakout, you can see that it's offset to the left. It's fairly close to the LCD here, and there's a gap here. Now for every set of inputs, there is an extra 70 millimeters on the length of the PCB. And it's all spaced perfectly. So the midpoint between the edge of the LCD and the edge of the controller, if you look at that, these two positions right here, the midpoint is right there. And I specifically position this board in this location because then the 32 port version will just extend by 70 millimeters. It will come to about here and it'll all fit perfectly. So so the first three holes will be in exactly the same position. There'll just be a fourth hole in the front panel that goes right there. And then the 32 port version will fit nicely into that same location. So what I was thinking of doing was, when it comes time to actually fabricate these and make some of the cases on my friend's plasma cutter, or maybe at QMS on their laser cutter, what I can do is make versions of the enclosure that simply have different number of holes. And it probably doesn't really make sense to make a version with just, just 8 inputs. The economics of it don't make sense because there's too much expense in the rest of it. But for example, it'd be possible to make a 16 port version with 2 holes, 24 port with 3 holes, 32 port with 4 holes. And the only difference is deleting holes in the enclosure. All right. So, mark down. Okay, so Ben said big ups to Aaron for the website. I think he was up till around 6 AM UK time last night getting this ready. Yeah, yeah. Ben, Aaron and I were in a private chat, and Ben kept telling Aaron to go to bed. So yeah, Aaron is probably rather sleep deprived right now. Yes. All right. So, yeah, okay, so there was a question about the different versions. I'm thinking about, sorry, I'm just doing a quick mental thing here. This is a squirrel slightly from the topic. Okay, I will mention it. I'll get into it, and then I'm going to talk more about the designators. Just get back to the OXRS site for a moment. Yeah, see on Aaron. Maybe Aaron just doesn't need sleep. So you can see here that on the 24 port version of this breakout, you can see that the address selection jump is here. The first chip has nothing selected, so it is at hex address 20 or 20. I don't even know how you say that in hex, because it's not 20 decimal, it's 20 in hex. So that is 20, 21, 22, 23. And you can see that the second chip has 1 jumper on it, and you just count in binary. The third chip has a jumper in a different position, and then 2 jumpers, etc. So the I2C addresses for those 6 chips are set as 20, 21, 22, 23, 24, 25. Now, that makes sense for the smaller boards, particularly the 1 and 2 breakouts, like the one with 8 ports or the one with 16 ports, because you might want to combine them with other things. And so being able to reconfigure the addresses is useful. Or you might want to, for example, use 2 of the 8 port breakouts together and daisy chain them and give them different addresses. So having configurable addresses in that situation is potentially very useful. I expect that most people will never change the address jumpers, but the capability is there if you do want to. Now, the thing is that with the 32 port version, which will come out to here, it'll have 8 of the MCP 23017s on it, and there are only 8 possible addresses for them, which means we're using every single possible address, which means you would never want to reconfigure them. It just wouldn't make any sense. It always makes sense to number them from left to right, so first, second, third, etc. And so I think the reason I'm talking about this is it came up in the chat. If you look at the design that I've got in here, so this is for the 32 port version, you can see it's still got these address selection jumpers in it. And the question, of course, is why did I bother putting those address selection jumpers in the 32 port version when we're using every single address anyway? Why not just hard code the addresses of those chips from left to right? And that would actually make the board easier to assemble, save a whole bunch of soldering, and it does have advantages. I would actually prefer it to be like that. But the reason is that I now have 4 versions of this PCB. And if I come across to the 24 port version, I'll open that up. So this is the 24 port version, which is the one that's actually physically in that prototype right now. And then there's the 16 port version. Basically, these boards are all exactly the same, just with the end cut off. And part of the reason that came about was from a maintenance point of view, because what happened was that I went from individual resistors on all of these to resistor networks, because it saves a whole lot of placements, and yeah, it's so much faster on the pick and place machine. It basically cuts the number of placements almost in a quarter of what it was. So instead of having to place 4 resistors here, you place 1 resistor network. So it's 1 part feed, 1 part pickup, 1 put down on the machine. So the placement time drops dramatically, going from individual resistors, and there were hundreds of them, to resistor networks. And so when I was doing that change, I realized that I was going to have to make that change on every single version of this PCB. The 8 port, the 16 port, and the 24 port. And that's a lot of work. I couldn't be bothered. I'm lazy. So what I ended up doing was taking the 24 port version, so I'll go back to this one, and I converted the 24 port version to resistor networks and got it basically as polished as I could, as complete as I could. And then I'm not going to save this, but let's see, I'm going to go, in fact, I'm going to do a very quick demonstration of how I did this. So what I did was, each time I make a change to, so I consider the 24 port version to be like the main or the canonical design, and the 16 and the 8 port versions are derived from it. So if we have a look in the schematic, let's have a, so this is kind of a laziness thing. So if I have a look in the schematic, and we've got the 3 ports there. So this is basically how I generate the, now which one is it? I've got to pay attention now. Hang on, I will, because I'm thinking on my feet here, what am I doing? That one, okay, so it's not that one. Yep, it is actually laid out logically. So to generate the 16 port version from the 24 port version, this is what I do. I go there, delete, and then come down the bottom and go remove. Yes, I'm going to remove that entire sheet. And then the new bottom sheet, remove that entire sheet. Yes, done. Okay, so now, oh, and also in the power supply I need to remove. I then go, I mean, this is obviously a very quick and dirty version of it, but this gives you the general idea. So I've just deleted a bunch of stuff out of the schematic, and all of a sudden our PCB is looking like it's got a big hole missing. And then So just clean up a bit of stuff here. I'm not actually going to do all the work because it's just not necessary. You get the concept. And then what I would normally have done is deleted some holes and things. I'm not going to do that. Go into the grid. So this is an interesting little trick. I know that the extra width on there is 70 millimeters, so I'm just going to change the grid size to 70 millimeters and go select, grab that bit and go move group, move left by 1 grid jump, and bang. A little bit of deleting, some cleaning up, and oop, that one was locked, so that didn't get deleted. Yeah, just hook together these last few traces, and like within 5 minutes I can go from the 24 port version of this board to the 16 port version, and I know that apart from relinking the tracks at the end here, it is 100% consistent with the 24 port version. And then to make the 8 port version, I just repeat the process. Delete 2 sheets, delete the I/O driver chip, delete 1 capacitor, 70 millimeter grid, move it in, bang, done. So that is the reason that I still have those address selectors on the large version. Now obviously I don't want to save this because I've just taken the 24 port version and butchered it. But so now that I've got this 32 port version of the board, save? No, do not save. Load? Yes. Okay, so now that I have this 32 port version of the breakout, this can be considered to be the canonical design. And if I need to make any other changes, like if I wanted to add different input protection or change, I don't know, power supply decoupling or different indicators or whatever I wanted to do, I would always apply it to the 32 port version. And then once it's done, I would just do the delete, move, delete, move, delete, move routine to generate the other 3 versions of the PCB. And that is why I still have these address selection headers on the largest one. And it kind of annoys me because I don't want them to be there. I don't want to have to do the extra assembly of putting these headers in. And what I could be doing is just tying these address lines directly high or low. I could get rid of this resistor network, or actually what I'd probably do is use the resistor network and just tie to either 3.3 volts or ground as appropriate. But anyway, it's a compromise, kind of. It's a compromise for my own convenience. Yes. Andy says, time to consider using I3C, which provides some backward compatibility with I2C plus dynamic address assignment. No. Replace them with dip switches. That's an interesting idea. Dip switches. Maybe. I'd need a dip. What? I'm just thinking about the footprint. So normally dip switches are on a 0.1 inch pitch, and then I think they're normally a 0.6, or is it a 0.4 width? I can't remember. So I could probably, yeah, it'd only take a tiny footprint change to replace these with dip switches. So that is an option. I don't know if that's better or worse. I'm curious to know. 0.4, okay, thanks Mariano. So yeah, dip switches are, yeah, of course they are, because they fit into the same footprint as a standard dip, like a dual inline package IC, which is typically, oh, Scott says 0.3. Okay, I'm not sure, I can't remember. Oh, right. I didn't even know I3C was a thing. I seriously thought that was Andy just making stuff up. But Sion, you looked into it. I3C. That's a squirrel. I'm going to resist chasing for now. All right, so since I kind of have a theme today and I'm on a roll with the theme, let's stick with the theme. until we end up until we end up I don't know, going off on a tangent. Now there are a couple of things that okay, so designators. I'm going to mention designators. I don't think this is really a huge deal, but it did cause a little bit of discussion in the Discord, so I thought I'd just clarify what this is all about. So if you're poking around on the OXRS site and you come across, oops, got to fix that, and you come across, oh, come on, I'm screwing up my OBS config. Got to put it about there, that's better, okay. Yeah, so if you are messing around on the OBS site and then you, sorry, my brain is all over the place because I'm trying to fix OBS while I'm talking, which is not a good idea. My mouth follows my brain. So if you're looking around on the OXRS site and you come across this thing which is acronyms, it might seem a bit strange. And the idea here, Steve, what's Steve doing in there isn't, oh, okay. No, sorry, this isn't what I was thinking about. Acronyms, this is explanation of the different acronyms, but no, what I was looking for was actually the explanation of the makers and the SKUs. Sorry, it's the SKUs is what I'm looking for. In fact, is there, I thought there was a page on here for it, but I don't see it. Maybe there's not. Docs, controllers. Oh, maybe the page doesn't exist on here. This discussion was happening, but I'll use this as an example. So this discussion was just happening in Discord, and I don't think it's actually ended up on the site yet as an explanation of what this SKU column actually means. So, and this index is going to have to be expanded dramatically, obviously. Now, what this came about from was trying to have an unambiguous way of referring to both components, like hardware components, and software elements like libraries and things. So we needed some kind of a naming convention to keep everything easy to follow. Now this one is possibly going to change because I don't actually want to use this extension. So getting to the point, the idea is that within the system, so within OXRS, we want to be able to have a designator that says this specific board and some way of referring to it. And so what we did was decide on having OXRS as a prefix, then a maker designation. So in this case, SHA is Superhouse Automation. And you can see there's one here which is BMD, which is Bedrock Media Designs. And then the third component is the specific board. And in this case, it says RC ESP32, so Rack Controller ESP32. I think I'm probably going to change that to just be Rack32. And you can see this extension is UIO16, so that's Universal Input Output 16 port. And we might have multiple people producing ESP32 based controllers. So the SKU would be unique because the maker designator would be different. And we might have multiple people making 16 port IO controllers. In fact, we already do. So I've got one, and there's the Bedrock one as well. So yeah, so OXRS is always the same. SHA is the maker designation, or BMD, or whatever it is. And then this is the identifier for the specific board from that maker. And there is no obligation for anyone to use any of these. This is just like an internal thing for OXRS to be able to designate stuff. So the SKU that the manufacturer uses might not be anything like this at all. They can have their own SKU. So we'll probably have like a maker SKU entry on here. Scott, yes, so we need a random squirrel generator. And let's just see where this goes. Okay, so that takes us to there, and that takes us to there. So right now, this whole thing only has 2 boards in it. It's got my Rack 32 board, and it's got James's, well, it's a picture of the smoke detector management board, but it's the UIO 16 port. But we want to end up with lots and lots of boards in here. They can all fit into the same chassis and can talk to each other over common connectors. Oh, Aaron, yes. So there was a link. I'm just going to click on this, which I think will take us to us. Okay, so this is what what Aaron, yeah, so Aaron just gave me this link. And this is the explanation. The community project is OXRS, the maker designation, and then the function or the hardware abbreviation. And this email address does not actually exist yet, so please don't try using it. Yeah, so, but this last part is arbitrary. That is whatever the maker decides they want to use as their SKU for their device. So yeah, that sort of documentation will end up on here as well. There's lots that we want to add to this. Now that we've got this, this basic structure in place, thanks to Aaron, we can now start putting in lots of documentation for the mechanical side, the software side, build guides for how to put a specific collection of modules together to build some device, and yeah, all of the other parts of it. Now, there is a whole thing which I have not even touched on yet, and it is probably a little bit premature, but it is such a cool thing that I'm going to mention it anyway. And that is, Aaron has been discussing with me a plan to make, how do I explain this? For those of you who are familiar with Unifi equipment, you will know about the management interface. In fact, let's just wondering if this is a really bad idea. I'm thinking about pulling up the management interface for my own Unifi gear. In fact, I will. Just because this will help illustrate what I'm talking about. I just have to extract the password from my... yes, I'm not sharing screen at the moment. Extracting the password from my hardware wallet. And... Desktop. Okay. So this is the management interface. So I've got I'm running a Synology NAS with the Unifi controller software in Docker, and this is just loading it off off that interface. So there is a dashboard with some basic information. There is a topology thing where you can see all the different devices. Oops. So you can see different Ethernet switches and different access points and all the clients connected to them. I'm not going to go into that in detail. Unifi devices. Ooh, oh, okay, hopefully they fixed some stability problems. So these are all the devices on my network. So you can see I've got 3 managed Ethernet switches, the Unifi security gateway, and a couple of access points. And through this interface, you can do things like add new devices. So if you add a device, say I bought a new access point and I plugged it in, powered it up, it could be discovered by the management system and appear here, and you click on a provision button and it becomes adopted and it becomes part of your network, and then you can manage it through here. So if I go into, say, AP Lounge, and once again I need to relocate my noggin out of the way. So we can look at information about that particular device. We can manage it, by doing things like restarting it. We can do firmware updates. We can look at RF information about it and RF environment analysis and all sorts of things. So I can manage the access points. I can manage Ethernet switches. You can see which ports have got stuff connected to them, the speed at which they're connected, statistics, and lots of information. So it gives a centralized management. I'll go into a different view. So it gives a centralized management interface for all of these devices that are on my network. Well, the devices that are my network, I suppose. And yeah, there's other stuff. So you can look at clients and pull up some statistics. Anyway, the point of showing you all of this is that what Aaron is proposing is a system like this for OXRS devices. So there would be a web management interface that would allow you to, so you could have a new device, stick it in a rack, plug it in and turn it on, and adopt it through this interface. And then it would give you a single unified management interface for it. And the other thing that I have not mentioned in any of this, there are really big subcomponents of this, each one of which is a whole subject in itself. And that is the work that Andy has been doing for many years in relation to MQTT device discovery, and that's a big topic. I won't get into that right now. But there is a project that Andy has been working on in different forms over many years, which includes some really, really clever stuff running over MQTT so that you can do auto discovery of devices and their capabilities. And yeah, sometime Andy needs to be on here with the live stream with me, and we need to go through that because that is epic. And where I see all of this going is taking this concept of the base hardware platform, so the convention for chassis designs, which should be easy to buy off the shelf or fabricate your own, modular electronics that goes into it, the firmware side of things, so you can write your own simple, I'm clicking around looking for where it was, but it's not there, the libraries to make it easy to do your own application-specific system, and the management interface where you can adopt devices and then click, oh, I want to reconfigure that one and change settings in it. And Andy's work on ICO, which is the MQTT-based service discovery and management system, which could end up being part of all of this as well. And of course the goal is 100% open source, which is always the which is nice. And the other thing, okay, so another thing that ties into all of this, this is something that started off as a little thing and it's sort of become a let's take over the world situation. There is a project that I have mentioned a couple of times in passing, so a few people have heard about it, but I have really not made any kind of a deal about it or explained it much because it just hasn't been in a state where it's ready to do that, is my IoT access point project. So I started doing this a couple of years ago, basically just using Raspberry Pis. And so what I've got is DIY access points that run at 2.4 gigahertz, so it's intended for IoT devices, and it allows the use of pre-shared keys without requiring support for PEEP or enterprise type encryption, because most IoT devices don't support it. So if you buy a Sonoff or a Shelly or any little IoT device with Wi-Fi, typically they will be 2.4 gigahertz Wi-Fi only, and they will not support enterprise encryption, which means you cannot issue a unique password to each device. If you think about your Wi-Fi network, you know, in a consumer environment, we are very accustomed to, you know, saying, oh, what's your Wi-Fi password? Because there is one password for the whole network. All devices have to know that password, and that is really, really bad design. But that's basically what we're stuck with. So the reason that I did this is that I've got personal pre-shared keys working in the gateway software running on the Raspberry Pi. So the Raspberry Pi acts as a Wi-Fi access point, and each device that connects to it, so every Sonoff or whatever, has its own unique password. They don't need to know anyone else's passwords, which means that if you want to change the password, you don't have to reconfigure 60 devices in your house because you've changed your Wi-Fi password. You can change the password for individual devices. Or if you throw out a device, no one can extract your global Wi-Fi password from the flash memory in the device. So anyway, I've got that whole project going on, and that would also tie into this. So conceptually, this whole thing could end up being like an open source equivalent or replacement for the Unifi ecosystem with not just Ethernet switches and access points, but with all the home automation I/O side of it, like light switch interfaces and smoke detector interfaces and all of that sort of thing. So the general concept is a Unifi ecosystem for home automation, and this is the foundational part of it. This is where it all begins. So I'm pretty excited about it. I think there's a lot of potential for this. And yes, so it's very cool. Okay, I need to stop for a drink. Right. I'm not sure what this is in relation to, but Aaron just said, yup, it's coming after I sleep. Yeah. Oh, Dodgy says, Ubiquiti menus are confusing. I 100% agree. I am really conflicted over Unifi. And so just to clarify, Ubiquiti is the company, Unifi is the device family, and Ubiquiti also make other device families. Unifi is the device family which is intended for small-scale deployments, like small businesses and that sort of thing, with this unified management interface. And so why I got really excited a moment ago when I saw that there are software updates available for these access points is because there have been known bugs in the firmware for their access points for years. There's a really nasty bug, which I won't go into right now, which relates to traversal of broadcast packets between 2.4 gigahertz and 5 gigahertz networks. And basically, it doesn't work. The packets silently vanish 50% of the time in like a sliding, I think it's a 90-minute window, depending on where the windows overlap. And there is a whole explanation for it, and it comes down to things like the way the designator of the packet is generated and when it loops around. So that is a problem for me. So the thing is that right now, my whole Wi-Fi network is 2.4 gigahertz. I've actually disabled 5 gigahertz on these access points because devices just break randomly, like every half hour, and then come back again. It drives me nuts. So what I'm really hoping is that this update that has just come out is maybe addressing that thing, because there's been a fair bit of discussion about that bug recently. Yeah, so Doji says it's too inconsistent. You're always looking around the screen to find what you want to adjust. Yes, and what I find is that it is, well, firstly, they keep changing things. And secondly, there are things that are in places where you just can't find them. Like if I go into settings, it's got Wi-Fi and networks, and like I'm not exposing anything bad here. Just my a Wi-Fi name thing. So the SSIDs are all here. So networks with IP ranges and things, security and internet. So, okay, now here, this is an example of what drives me nuts about this. It is, I want to change firewall rules for allowing incoming connections to my external IP address to on a certain port to be mapped to a certain internal machine. You know, the classic thing. You want to punch a hole in your firewall and port map it through to an internal service, which is a really, really common thing to have to do. And you come to the settings, where do you do that? It is actually, it's spread across multiple locations, and so there's a networks thing, there's a security thing here. We've got internet threat management, or maybe that's it, or traffic and device identification, I don't know. Maybe it's under internet. Oh, we've got a WAN connection here, so maybe it's in there, I don't know. Okay, let's go back to security. Internet threat management, I'll have a look in there. Does this look like it is? Oh, look, we can set a threat level. Oh, there's a firewall thing in here. Okay, so I'll go into firewall. Rules. Okay, so we've got some firewall rules. I want to create a new rule. And then when you're in creating a rule, you need to, I'm not going to go into that because I'll start exposing things I don't want to expose. It then, say you want to create a rule that allows from a certain port to a certain destination port and IP, but you can't do it on the spot because you have to create a host group. So then you go to create a host group, and then you go back to the firewalls, and then you select the host group. It drives me nuts. It is totally obscure, even for someone who has been doing, like setting up routers and that sort of stuff. When did I start doing that? 1994, I think it was. No, a bit earlier than that. I would have started setting up routers probably in 93-ish, give or take. And I kind of know what I'm looking for. I'm definitely not an expert, but I've done it many times and I know what I'm looking for, and in the Unifi interface I can't find things. Anyway, sorry, I ended up on a rant about Unifi. Okay, so I'm ranting about Unifi and how frustrating it is, but the counterpoint to that is that it is also really, really good. It's a system that solves a problem. It's just that there are certain things about it. I get passionate about it. If I didn't care about it, I wouldn't be frustrated by the things about it that don't work the way I would like them to. But I really do like Unifi gear and their system in general. So when there are certain things about it that are not optimal, it kind of gets to me more than it should. Anyway, where were we? Okay. Sean said, I changed back to pfSense for this reason. Yeah. Yeah. Yeah, Tiago says, the new UI have missing configs. Yes. And sometimes it seems that they change things just for the sake of changing it, like to make it feel new and fresh. And yeah, that is not necessarily a legitimate reason for changing things. Yes, okay. Yeah, and Tiago says, some things can just be done in classic interface. Yeah, the one that really got to me, up until the moment they did this, I was like 100% pro Unifi, they can do no wrong. And then what got to me was when they went to the, I think it was the 6 series management software, in topology and floor plan. Oh, look at this. I had my floor plan set up in here. In fact, I did a video where one of my my setup videos, that's the other thing, is that when you keep moving things around, things like tutorials and documentation and videos just become out of date. They become irrelevant. I had my floor plan set up in here, and I could do things like check coverage. So I could plan, okay, I need to put an access point here and an access point here and see how that coverage works across my house, taking into account things like the material that the walls were made of, etc. And when it went to the 6 series, it just went like this. Gone. All of the work in setting that up, gone. And it just says coming soon. And then now you have to go to the Unifi Design Center, which is like an online thing that is not related to your... they took something that was good and they just took it away. That annoyed me. And after that happened, I started seeing all of the nitpicky things. But I'm getting into a negative thing about Unifi, which is not the point. My whole point is I actually do like Unifi, and I like this model of having devices like this all managed through this single interface, so that you don't have to log into each of your Ethernet switches individually, log into each of your access points and change configurations on them. You can just set a policy and it applies automatically to all the devices. It's much nicer. So with what Aaron is talking about, our goal is something like this interface, conceptually, with all your devices displayed here, and being able to adopt new devices and configure them through this. And have that as the software front end that sits on top of boards that are built using this open extensible rack system. Oh, that would be really, really cool. Dodgy says, I haven't updated firmware lately since their data stealing problems. Yeah, they've had some other issues as well. And in fact, these, yeah, there's that. And, oh, excuse me. One of these access points is running the most recent firmware up until this update came out. The other one is running firmware from about a year ago, because I actually specifically went back and found old firmware and loaded it onto the access point because it made it more stable. So I was running one with current firmware, one with old firmware, just to try to get the best of both worlds. Anyway, where were we? I don't know. I've been jumping around a whole lot, even though I actually have a specific topic today, which is OXRS. Almost time to go and get myself some hot dogs. You're talking about lunch already, Stephen. What time is it? 11:43. I suppose because I started so late, it feels like I've only been streaming for 20 minutes, but I've actually been streaming for an hour and a half. Somehow it happens. Yes. All right. Now, let's see what you are all talking about in the chat. David said, I reverted to a classic UI. The new UI has a lot of problems. Not sure if you can do that if you have a Dream machine. Yeah, I don't think you can with the UDM. So, right. Yes. pfSense, yes. pfSense is a good solution. That's actually what I was running before I switched to the Unifi security gateway. Right. No, I was running OpenSense. No, I was running pfSense for a while, then I switched to OpenSense, and then I switched to USG. Right. Okay. Now, Aaron Aaron is getting us back on track here. Hang on, I'm going to hit mute for a second because I need to cough properly. Is mute working? No, mute. Mute. That's better. All right. Now, Aaron was talking about the case design. Yes, this is important. This is really important. So, we need to get back to this whole thing of the case design. So, one thing we need to do is, sorry, I'm clicking around on here and you can't see it, my usual problem. What we need to do is, and once again, move that out of the way. Do some of the documentation for the mechanicals around this area here. So this front part of the faceplate, where these holes need to be cut, and over this side, this part of the faceplate where the hole needs to be cut for the LCD. So there needs to be some, we need some mechanical drawings showing that to allow people to start working on their own cases, and also to progress the case design. So the idea is that there is going to be, what have I done to my zoom? Actual size, that's better. So what there is going to, how I want to go about this is, I'm going to work on case designs that I will fabricate myself, and those designs will be published. So anyone that wants to go out and just do local fabrication, go for it. You can take those designs and do it. You'll be able to buy the cases if you want to, just to get the benefit of the economies of scale. And if you don't have access to someone that can do laser cutting for you and all of those sorts of things, those are big barriers if you just want to build one device. So it'll be much easier if you can just go out and buy a chassis ready to go. And that will be like a reference design or a reference implementation, but the mechanicals around the critical parts, like the front panel cutouts and the mounting holes for the PCBs, will be provided as mechanical drawings. So if, for example, you wanted to design your own enclosure, and maybe you want to design an enclosure that isn't rack mounted, maybe you want to make like a desktop case that doesn't have the rack ears on it, and it's narrower, or whatever variation you wanted to do, you could take that mechanical information about this portion and apply it to your own enclosure. Some people may want plastic enclosures, or steel, or aluminium, or open enclosures like this one that you can see here, or fully enclosed, or they might want to make a deeper enclosure. You should be able to do all of those sorts of variations to suit your own needs, as long as the critical compatibility elements are the same, like the front panel cutouts that go here. If you have the same cutouts and you can mount the same boards in it, it doesn't matter what your enclosure is made out of. You can come up with your own design and sell it, or just use it for yourself, whatever you want. So I suppose the levels of effort would be to buy one prefabricated, kind of like what you see in the photo, or if you want to fabricate your own, take the existing design files and fabricate it, or take the design, like the reference parts of the design, and design totally your own enclosure and fabricate it. So all of those options should be catered for. And whichever way you go, the idea is that it'll still be compatible in terms of connectors and dropping in PCBs and things. So you might want to design a... so one thing that I think would actually be quite cool, I've been thinking about doing this, but I can't do everything at once. I've got to serialize the effort, is doing a version which is like a mini enclosure with, say, the rack 32 board in it, perhaps a 16-port I/O breakout, and the LCD, and make the whole thing about half the width of a standard rack enclosure. Probably make it the same height as the rack enclosure, just because the design's already done, and like the same height, the same depth, just make it half as wide with no rack ears on it. And then it's just like a desktop or a wall mountable version of the controller in a much smaller form factor. But it would still be interchangeable in terms of, it'll run the same software, it can have the same PCBs in it, and yeah. Anyway, so it doesn't have to be rack mounted. So that's, the naming of this is, it's a little bit whimsical. But yeah, it all started as a rack system, but it doesn't have to be just for rack enclosures. These could be desktop devices or wall mount devices or just things you stick inside your ceiling or whatever you want to do. That's where all the mechanical part of it comes in. Now, sorry, I've got to get back into the chat. I can't actually see the chat right now. So what are you talking about? What are you all talking about? All right, replaceable fronts. Yes, Scott said replaceable front panels. And Aaron pointed out the aluminium Unifi UDM Pro case is a really interesting design to allow for a separate faceplate for DIY makers to customize, but also easy machining at home. Also no visible screws. Yeah, that is really a really nice way to do it. So yeah, I think a lot of the discussion now is going to be around the enclosure, because that's going to be the thing that will hold us up next. We now have the RAC32 as a working controller, and we have a CM4 controller that will be coming soon, and I think there's probably going to be like an ATmega 2560 controller coming soon. We have the LCD, and we have multiple options for the I/O boards in the middle, but at the moment the only enclosures in existence are the ones that I have done kind of by hand. So the basic shape was done on a laser cutter and then CNC folded, but all of the cutouts on the front were done by me by hand with a drill and a file and an angle grinder and a lot of annoyance. So getting to the point where we can fabricate the cases and get that into people's hands is going to be the key to helping this progress and start building up some of these devices. I don't get that. What's the off microphone dead zero? I don't know. I don't understand, Henrik, what you're getting at there. I'm pretty sure I'm not muted. All right. Yeah. Okay, so getting to this. One of the things that I want to produce is a version of this with the cutouts already done for the LCD and the controller, but just a big blank in the middle so that it can be cut to suit whatever you want. Now that situation is best if it can be done on a flat panel, because then you can mount it flat in a CNC machine and you can cut the holes out on a CNC machine, which many people do have access to. The thing is that if it's in an enclosure like this, this all started as a single flat piece of steel, and it was laser cut and then folded. By the time it's folded, you can't easily mount this in a CNC machine in order to cut these front enclosures, just because of the way the base and everything sticks out. It could be done. You could make some kind of a jig, like a fixture, to hold this, but it would be really annoying. It's so much easier if the front panel can be a single flat piece that attaches to the rest of the enclosure, because then you can make the front panel out of milled aluminium, or it can be PCB, so you can just design a PCB and use that as your front panel. There are lots and lots of options. So I really like the idea of coming up with an enclosure design where the front panel is a single flat piece, because it's just so much easier from a machining point of view. And it also means, from my point of view, it's easier to produce different variations of this, because if this whole thing is a single folded piece of steel, then whatever the front panel cutouts are has to be done before the folding takes place, And it means that I'm going to have to fabricate a bunch of every variation and have them sitting here. Whereas it's much better if the base chassis can be exactly the same for all of them, and it's only the front panel that is different. Because then what I could do is fabricate a whole bunch of the chassis and make them all identical, and then just have different front panels. So that's the goal. And that is really where, yeah, as T. Fisher says, you can even order aluminium PCBs nowadays. Yeah. So JLC PCB recently started doing aluminium PCBs, and they are surprisingly cheap. Sorry, my my throat is not good. Oh, Ron Close says a nibbling tool works well. Only barely with a with the 1.2 millimeter steel. So these rectangles, they were partly cut out with a panel nibbler. I've got a, is it here? No, I think I might have left it out. In the back of, my panel nibbler is still in the back of the garage where I was using it. So, oh, Scott says copper or brass front panel, steampunk IoT. Yeah, I actually machined a, on my CNC machine, I think it was 2 weekends ago, I machined a copper PC, a PC, you know the boards that go over the back of a PC motherboard, and there's a name for it, and right now the name just escapes me. It goes into the back of the enclosure, and it has all the holes for things like the USB socket and that sort of stuff on it, and then you put your motherboard in place and all of the connectors come out through it. That rectangular piece, I machined one of those out of copper for a for a classmate of my son's who is building a steampunk PC as part of a faceplate. Yeah, IO Shield, that's it. IO Shield. Thank you, Aaron and Stephen. So the IO Shield, he's building a steampunk PC as part of a class project, and so he brought over a piece of copper sheet for me, and it was horrible to machine because it's soft, and the machine doesn't properly take chips out of it. It kind of just smushes its way through. But yes, that can be done too. It is time, just about. It doesn't feel like it, but it is time just about to wrap up this live stream and go and hang out with my family, have some lunch. So, copper is gummy. Yes, it's too soft. So instead of making chips, it tends to just make mush when you try to drive the CNC machine through it, drive the cutter through it. All right, so, oh, there's a link. What is this? Aaron says, I'm just opening the link that Aaron sent. Internal photos, test report. Cool, okay. Yeah, I have got a very big stack of rack mount equipment sitting in my garage, and my plan is to go through and yeah, have a look at different ways that this has been done. And of course there are also a bunch of people on the Discord that have, I'm just looking for faceplate information. There are a bunch of people on the Discord who have been putting up designs for enclosures as well. So there are ideas about different ways to do it. I'm not going to go through all of this now. I'm going to look through this later. Thanks, Aaron. And we'll figure out a way to make some. Anyway, I am going to wrap up this live stream now. Pretty much on time, and it feels very, very short, but hopefully it was interesting and useful. I'm really excited about this. So this is something that came about kind of unexpectedly. It grew out of something that was a single project, and then I thought, why not? Why not apply it more broadly? Case fans. Oh, that's a good point, Dodgy. Maybe we need to start thinking about that. PoE module. Okay, sorry. The quick update is that the PoE modules have not yet arrived, which is very sad and frustrating. Going back to the overhead camera, what you can see on here is the footprint where the PoE module goes. So at the moment I can power this through the back power connector or through PoE with these jumpers in place, which bypasses the regulator module and just feeds the PoE power directly into the onboard voltage regulator. And so I'm sending 12 volts down it and it works. So if you've got DIY PoE, this works. But I am still waiting for these PoE regulator modules, which I ordered from a Chinese supplier. And the postal service in Australia is just in a shambles at the moment. So I got a notification, I think it was something like 2 weeks ago, I got a notification saying that the PoE module, so the shipment with the modules, was in the country. So they're possibly even in Melbourne, like they could be 20 kilometers away from me, and they might have been there for 2 weeks and they just haven't been delivered. So yeah, we've got really big problems with our postal service at the moment. It's been struggling and sort of recovering and struggling and recovering. But with the increase in COVID cases recently, it has got to the point where it is just about fallen over. I'm not going to chase this squirrel for too long, but basically a dramatic increase in demand. So people who are doing online shopping because they don't want to go out to the shops. So the volume that is being seen for online, for parcel delivery now, when are we? Start of September, is about equivalent to the Christmas peak. And so what we're seeing now is like an unprecedented levels of parcel deliveries, combined with, I got a message, there was an email that was sent out by Australia Post a couple of days ago to the business customers apologising and saying that they were suspending parcel collections for about a week because on average, on any one particular day, Australia Post has around 500 staff who are off work because they either have COVID or they are in isolation because they are close contacts. So they are 500 staff down and seeing Christmas levels of activity. So the result is that parcels that should take a day or so to cross town end up sitting in a warehouse for weeks. And that's unfortunate, it's just the way it is. So yeah, it's difficult times. Peter said, log off, John, delete your account. One quick thing I'll answer. So Ron said, are you using 48 volt PoE? It will. That's what that module is for. And Peter, don't worry, this is going to be the end. So the module that goes in here is the 802.3 AF compliant regulator module. So that will allow this to support 48 volt PoE and talk to commercial PoE switches like Unifi, Ethernet switches with PoE. And so that's what I'm waiting for, is that regulator module to drop in there. In the meantime, these jumpers allow it to run from 12 volt PoE. So if you've got an injector, like just a regular, like a cable splitter type PoE injector, and you feed 12 volts down it, this will run perfectly happily. But when that regulator module arrives, we will be able to support 48 volt PoE. Okay. So I am going to call it there because I need to have lunch, and Peter is going to start sending me SMSs directly if I don't get off. Okay. Anyway, that was fun. Thanks for coming along and talking about the OXRS, and I'm still embarrassed about the OXRS acronym, but oh well, it's just the way it goes. The Open Extensible Rack System. I think this has got legs. I think it's a cool thing, and I hope that it allows people to build projects that that would otherwise be just, you know, too much groundwork to do to get to the part that they actually need. So if you are interested, please do two things. First, the site oxrs.io, which is, as you've seen, is still very much a draft. And second, go and check out the Superhouse Discord server. I'm going to just put that URL in there. In fact, I'll drop both these URLs into the chat. So this is, oops, this is the site which is slowly coming together for the Open Extensible Rack System, and this is how to get onto Discord, which is where everybody's hanging out and chatting about all of this. Trung asked if there is pricing. That is a very complicated question I'm not going to get into because there are so many components to this. It'll be possible to buy the chassis on its own, the control boards on its own, the I/O modules. Different makers are going to be making their own I/O boards, so that it's not one price. It is a whole family of devices which you can buy individually or together as a complete assembled unit. So yeah, that's a very open question. There will be things like my light switch controller that you'll be able to buy as a single complete unit, and there will be just a price for that, or you can buy any of the modules, or you can mix and match and make your own, which is what all of this is about. So thank you very much, everyone. I hope you have a good Father's Day for people that's relevant for. And I will see you all very soon on another live stream or on Discord. So, oh, and thank you very much. I saw there were a couple of people that put in super chat donations. I really appreciate that. Thank you very much. That does certainly help a lot. And I will catch you all later on. Bye.